Okay, so we are talking now about matrices, and the basic is the matrix. First, I show you how to identify size of the matrix and the squareness. Okay, the size of the matrix becomes from how many elements in the matrix have. First, there is let's say this kind of matrix. So here is the rows, and here are the columns. And so on. This kind of matrix is 2 rows and by 3 columns. So this is how the matrices are marked. And when it's squared, there is as many rows as squares. So this isn't square matrix, but if we made this kind of matrix could have anything inside which are numbers or pi e or something x or anything, but I put 9 over there. So this is a squared because it have 3 rows and 3 columns, so it's 3 matrix. Okay, so to next thing, how to compare matrix equality. You cannot some matrix have to be all elements, and matrix have to have numbers or something markable inside. It could be letter or anything which are in use, but it have to have. Example, if I have a matrix like 4 minus 1, this kind of matrix. So I had only 2 elements in this column and 1 element in this column, so this isn't matrix. So this is undefined. How it is spelled? Undefined. And so on. This isn't matrix. And it have to have all elements, and it have to have be that is quite that. So how to perform addition of matrix. When you addition matrix, you have to have as many elements as if I try to add this matrix plus this matrix. This isn't possible because there are there are more elements than in this one. So this isn't possible. But if I add this one to this kind of matrix, so we had a new matrix, because there is as many elements as in the both side in the both if we marked this one A matrix and this is B matrix. It's a capital and a bolded, so there is a matrix. When the vectors were bolded little letters or marked like this, matrices are marked like this, so on. These could be calculated like this one. There is a 5 because this element is excuse me, let's change color. This element is added to this element and this element is added to this element and so on. So we have first rows and 10 columns, or first columns or 10 rows. Anyway, the elements are summed together by this, and this is like that, and that is becoming that one, and this one, and this one is becoming that one. So we have this kind of matrix then. Okay, then let's take a new one. Let's see where we find clear all out. Let's delete. Oh no. Let's delete everything. Okay. So, and then we have a next question. What is a negative matrix? So we have a negative matrix is something like this one. Let's make it a little bigger size. When we have a regular matrix like this one, then when we had a negative matrix, it is multiplied with -1. So this is a scalar and works as similar as in the vectors. So we add so we multiply the whole matrix with this scalar. So we had a negative matrix like -1, -3, -2, -5. So this is the negative matrix, negate matrix. Then how to perform subtraction of matrix. As we knew first that the A plus B were C matrix, so we can now do the negative B if we wanna subtract like A plus minus B is some D is the same that A plus minus 1. Oh, bad one. B is as D. So we do the subtracts as same as addition, but with the negative. So it's just calculating. Then how we transpose the matrix. So if we have a matrix like 1, 2, it's a quite, and this is a, let's make a D matrix. Looks like O D matrix. So the transpose of let's make a little more elements for this. So it's easier to show you. Like 4, and then there is 5, 3 minus 1, and 11, then 9, and then there is 15, 12, and let's say this is like 8. Okay, there we have a matrix, and this is our, and here is our transposed. So when we transpose the matrix, we have to change the addition, like the rows are now the columns and the columns are now the rows. So when we have a first row here, the 1, 5, 11 and 15, like 1, then it's transpose D is like the row is a column, and then the second row is a second column, so 5, 2, 3, 10 and 12, and then the third column is the last one row. So in this case, so here is our transposed. So as you see that there are not this column, this matrix is 3, 4, so this is like 4, 3 matrix. And the last question was to determine the matrix symmetric. So the symmetric matrix is when, when the, let's say this is A, three, 5, 2, 4, 3, 4, and let's say this is a 1. This is symmetric because when we made a transpose of